Okay. One guy actually saw a problem with this. It's called as Mac costing. So what he saw was that you put in any page that's fetched and it's added to the browser. Now what if I give a URL which is hosted on a different domain, right? Now normally in HTML4, if after hash, if I had to give a page located on a different domain, it will never get fetched because of the same origin policy. But HTML5, basically breaks this because it lets you create Ajax request to any domain, right? So now the same script will fetch evil.site payload.php, right, using the Ajax request, and it will add the response to that page. So it's kind of like a cross-site scripting vulnerability, right? So I'll show you a quick. Okay, so because of this XML HTTP request, any data which goes into it is actually a prime suspect for DOM-based XSS vulnerabilities, right? So this is one additional thing that you have to look out for when you're doing pen testing. So I'll show you a quick demo with this as well. Okay. All right, so this is a sample site. Click on about. So you can actually see I'm still staying on the same URL, but it's just the value after hash that changes, right? Click on services, career. So this is what is actually changing, right? So now, to exploit this, I'm going to include a page which is located on a different domain. So this time I'm fetching a page from 192.168.237.139, and it actually executes JavaScript from that remote domain, right? So this is a new type of DOM-based cross-site scripting vulnerability which you have to look out for. Any questions on this? Yes.
How do you mitigate this?
How would you mitigate this? Yes. Now, actually, this is one place where HTML5 has created a problem for regular websites. So, what you would actually have to do is, in this section of the code where you right. So before, so what's happening here is you just get the location.hash value and you put it directly into the XML XSchar API. So what you have to do is, before you put it there, you actually have to validate it to find out if it belongs to the same domain. You could write a regex, for example, to verify if it's just a file path or if it's a URL pointing to a different domain, right? That's how you mitigate it.
Okay, so can we see that it is analogous to the mitigation which we use for the DOM-based XSS? What we do is we validate the input given after the hash.
Right.
Same kind of
thing, yeah. Right. The only thing is, normally in a DOM-based XSS, you don't consider data going into XML HTTP request as something that will give you trouble. But now it's a new API that you have to look out for. Right. Any other questions? That was a really good question. Any other questions? Okay. So I guess I'll go to the next one. It's called as cross-site posting, which is basically the reverse, or probably a little twist on cross-site remote file include. So if you look at cross-site posting, it's not actually about injecting a script into the page, right? But it's simply about sending the data from that page out to a different domain, right? So like in a similar kind of setup where, now let's say this page is not being fetched and added to the domain, right? But the only thing is, if you enter some data, if you click submit, right, the page to which it is being sent is fetched from location.hash, for example, right? So now by changing this location.hash value to my domain, when the user fills in a form and he clicks submit, the data is actually sent to my domain, right? So again, this is a variation of this that you have to look out for. Alright, so then here we come to the actual new stuff. One is network reconnaissance. You might have heard about port scanning from JavaScript, right? It's actually a pretty old trick. I think it was first discussed probably way back in 2005, 2006, right? The problem with the old approach is it does not work anymore. And even when it did work, it was not reliable at all, right? And even when it was reliable, it could only tell you if a port was open, right? It never told you if a port was closed or if it was unreachable. So there was only one state that you could determine: either it was open or you don't know what's going on with it, right? But with HTML5, you can actually say if a port is open, closed, or filtered, and it's reliable most of the time, right? So HTML5 has a couple of new APIs. One is called as cross-origin request, XHR, and the other one is WebSockets, right? So using these two new APIs, you can actually do pretty reliable port scans. Now, WebSockets it's kind of similar to XHR in terms of usage. So like in both of them, once you establish a connection to a remote port, and both these APIs can make connections to any IP address, any port, right? Same origin policy does not apply to them. So when you normally make a connection, you have a property called as ready state, right? So this property actually tells you what the actual state in which this this connection is in, right? If the connection has been established, or if it's been torn down, or if it's in the process of getting established, right? And ready state has values ranging from 0 to 5 for XHR and 0 to 4 for WebSockets. Now, the interesting thing is, when you try to connect to an open port, the way in which the ready state value changes is different from the way in which it changes when you connect to a closed port, right? And when you connect to a filtered port. So what you basically do is you create a connection to a remote port, and you basically monitor the ready state, and you see how it is basically changing. How much time it takes in value 0, how much time it takes in value 1, and by observing these changes, you can actually say if a port is open or closed, right? So that's how this technique actually works. Now the thing is, with this kind of a port scan, we are not doing a socket level scan. If you do a port scan with Nmap, it sends a sync packet and it looks at the kind of response it gets. So it's a socket level scan, right? But this one is not a socket level scan, it's an application level scan. Because the kind of connections we are creating are all HTTP based connections, right? So one thing that we have to consider about is the kind of application which is running on the remote port. So there are 4 kinds of applications. Okay, so there are some applications, when you tell that to them, right, you will just see a blank screen, and it will not disconnect the connection, right? It'll be a blank screen and it will still be open. Probably it's waiting for some control packet to be sent from your side, right? So these kind of ports can't actually be determined if they're open or closed, because the way in which they behave is probably not useful to us. But there are a lot of other ports which, when you connect to them and when you send a packet, and if this packet is not in the same protocol which they support, they immediately terminate the connection, right? And this happens for a lot of applications. So these kind of applications these kind of ports can actually be determined. The status of these ports can be determined if they're open or closed. So these are some details about the timings of the ready state values. I'll show you a demo, using this as well. Now that the technique that I spoke about now is for doing port scans, right? You can actually extend this to do a network scan as well. The reason why you can do that is because using this technique, you can even discover closed ports, right? So what you have to do is you pick 192.168.1.1 starting IP, ending IP is 192.168.1.255, and you just scan for any random port. Let's say port 339 or port 445. The kind of ports which are normally allowed through the personal firewalls on a personal system, right? So irrespective of the status of the port, whether the port is closed or if it's open, you are still going to get a response back, right? So you will kind of know if that machine is up or not. If a machine is not up, then it'll turn out to be a filtered port, so you can say that machine is not live. So that's how you do network scanning using this. And if you just combine it in a smart way, you can actually determine a person's private IP address, right? So that's a tool that I've written called JS Recon. I'll show you a quick demo with that. Alright, so this is JSDcon. I'll just do a simple port scan. Right, I'll scan my home IP address. Scan from ports 440 to 450. Right, and you can scan either using crosshouse and request or using WebSockets. You can use either of them. But the catch is your browser should support that particular feature. If you're using an older feature, older browser which does not support it, the scan wouldn't actually work. Right, so it tells me port 445 is open and these ports are closed, right? So this is, what do you say, very reliable result because you don't have anything here in terms of filtered or application type 3 and 4. Application type 3 and 4 are the kind of applications which, when you connect to, they just have a blank screen. They don't close the connection. I said you cannot determine the status of those ports. But the ones that it was able to find are both in open and closed connection, so these are actual results. You can actually trust them. So you can do a network scan and you can use it for discovering your private IP, but the only catch is your IP should fall within this range, right? Because I've designed it that way, but you could probably extend it to discover private IPs in any range. Right. So any questions on this? Nope. All right. Then I'll go to the next section, which is HTML5 botnets. This is the last section that I'm going to cover. Alright, so in this section we'll basically look at how you can create a browser-based botnet using HTML5 technologies. And the API that I'm going to use is called as web workers, right? Web workers is a new feature in HTML5 which lets any website start a separate thread, a background thread, right? Which is going to execute JavaScript. Now, normally, anybody who has been into web development would know that on any page, if you have JavaScript running continuously for more than 20 seconds, right? I mean, in some browsers even 10 seconds. It'll freeze the page, right? And if you're using a browser like Firefox, it'll probably freeze the whole browser. You have to kill the process and restart it again, right? So you are never able to do anything process intensive using JavaScript, in the old days. But with HTML5 and with web workers, you can start a thread which will run in the background. It can run for even 6 hours, and you wouldn't even know it's running, right? It's because your page is going to be just as responsive as a normal page, right? So this creates a lot of interesting possibilities because now you can run JavaScript for extended periods on different browsers without the users actually knowing about it, right? So we basically use this to create a botnet. Now, why would you want to use JavaScript for creating a botnet? Botnets are usually something which belongs to the domain of native code, right? So what usually happens is you find a 0 day on some popular product, usually on Windows, and then you get people to visit some website probably, and then you execute code in their browser, and then you install your botnet client on these machines, right? And which eventually talk to a command and control center, and that's how a botnet traditionally runs. But there are some advantages in using JavaScript. One is you have a very huge user base, right? Any person who has got a browser can actually become a part of a JavaScript botnet, right? You don't need a 0 day for it. You just have to get somebody to come to a page. And anybody who probably comes to my site, right? They're executing my JavaScript on their browsers, right? So it's kind of like code execution. The only catch is JavaScript has limited control, right? But so we look at a few things which JavaScript can actually do with this talk. So the fact that it's actually very easy to get your code executed on somebody's machine makes JavaScript probably the best language for writing a botnet in. And the fact that there are billions of people who could probably become zombies.